Okay, this is going to be an exercise that is optional. You don't have to do this if you already know how to factor and you're pretty proficient at it. But one of the skills you're going to need to have not only for this fall for your calculus class, but also for the next couple of sections. When we work with polynomials, we're going to need to be able to multiply and especially to factor those polynomials, in particular when we deal with rational expressions, which will be the quotient of two polynomials, and we need to simplify them. So I teach factoring a little differently from what most algebra teachers do. My method is sort of based on trial and error, but it's not really random trial and error. It's a very organized trial and error method, and it's based on the idea of greatest common factors. So before we actually begin with teaching you to factor, we need to learn to multiply, because the multiplication, the product, is what we actually factor back into the original two pieces. So here we have a couple of binomials for our first example, 3t minus 2y and 3t plus 5y, and we're going to multiply those polynomials, and we're going to do that using a multiplication table. And my multiplication table is going to hopefully look pretty familiar to you, because way back when you first learned about multiplication, you had a table that was rows times columns, and if you wanted to find the product of two numbers, then you would find the intersection of the row and the column containing those two numbers, and that gave you the product. So we're kind of doing the same thing here. We're going to build a multiplication table. And the way that we're going to do that is we're going to put the first factor in the top set of boxes. That's going to be 3t minus 2y. And then on the side, we're going to put the other factor, which is going to be 3t plus 5y. And it's very important that you keep track of your signs, so don't leave any of your signs out. So the first thing we'll do is we will multiply the first row element times the first column element, and 3t times 3t gives us 9t squared. And then we're going to take the second row times that first column, and that gives us positive 5 times 3 is positive 15. And then ty, just keeping them in alphabetical order just because. And then we're going to multiply the first row times the second column, and that's going to give us 3 times negative 2 is negative 6 ty. And then finally, we're going to multiply the second row times the second column, and that's going to give us positive 5 times negative 2 is negative 10, and y times y is y squared. And what you're going to notice here when we do these problems like this is that the idea of like terms, you have to combine your like terms. Those like terms are always going to be on the positive diagonal. And so plus 15ty and minus 6ty is are like terms, and therefore our final answer for this problem is going to be 9t squared plus 15 minus 6 is plus 9 ty minus 10y squared. And this is the product. So we'll practice with that a few times to make sure you understand this process. Then we'll move on to the lesson about factoring. So our second problem here says that we're going to take the binomial 9k plus q and multiply it times the binomial 2k minus q. So we are multiplying, and we have 9k plus q and 2k minus q. And again, doing exactly the same thing we did before. We're going to say 2k times 9k is 18k squared. And negative q times 9k is negative 9k q. And 2k times positive q is positive 2k q. And negative negative q times positive q is plus q squared, minus q squared. Sorry about that. Positive times negative is negative. And again, we see that we have like terms as well as the first term and the last term, and so our final answer is going to be 18k squared negative 9 plus 2 is negative 7 kq, and then minus q squared. So remember that your like terms are going to be on the positive diagonal, the one that are going up from left to right. And here we have another one. We have 2 minus 3x times 2 plus 3x. And of course, 2 times 2 is going to give us 4. Positive 3x times 2 will give us positive 6x. 2 times negative 3x will give us negative 6x. And 3x times negative 3x will give us negative 9x squared. And again, we look on the second and the third boxes if you're counting from the top, and we find that we have like terms, negative 6x and positive 6x, but in this case, the product or the sum of those two terms is 0, and so our final answer actually only has two terms in it, even though it's actually 4 minus 0x or plus 0x, whichever way you'd want to write it, minus 9x squared. We generally leave out the 0x and just say that that's 4 minus 9x squared. And we're going to see something similar happening on our next problem, because on this one we have 6m plus 5 and 6m minus 5. And so we're going to multiply those two. And 6m times 6m is 36m squared. Negative 5 times 6m is negative 30m. Negative 5 times, 6 times positive 5 is plus 30m. And then finally, negative 5 times positive 5 is negative 25. And again, we're going to see that positive 30 and negative 30 will cancel out, which gives us that same zero middle term. And so our final answer is 36m squared minus 25. And I want you to notice that this process is actually no different from what you normally would have called FOIL. The real true difference is that it's just organized a little bit differently. This is first times first. This is your inner and outer terms, and this is your last times your last. So it really is working the same way as the process you've seen before. And so our last example of multiplication, we have x plus 2 squared, and I put this one in here deliberately because I want you to remember that you don't just deliberately distribute that squared. This does not equal x squared plus 4. If you do that, you totally lose your middle term. The correct way to multiply this out is to multiply x plus 2 times x plus 2. So it is in fact still the product of two binomials. And that means that x plus x is x squared, 2 plus x is 2x, x plus x times positive 2 is plus 2x, and 2 times 2 is 4. And you see here that these two terms didn't just go away. You have to combine those like terms, and so your final answer is x squared plus 2x plus 4. I'm sorry, plus 4x. My bad. Because 2 plus 2 is 4. So, our next step is actually to go backwards with this and talk about how you would factor. So when we learn to factor, the first thing you need to always look for, you always check, your first step is to look for your greatest common factor. You may not even need to do much beyond that. So looking at 7, 8 to the third power, and 14, 8 to the second power, I see that 7 will divide into 14. And so part of my greatest common factor is 7. And then I see that both of these have a raised to a power. And so they have a common factor of a squared. You always use the lowest power as your greatest common factor. So that's going to be 7a squared as your greatest common factor here. Now you can use the factoring boxes to do this part, but most people actually, I think, find it easier to do the greatest common factor part of it this way. Take your terms, and divide both of those terms by your greatest common factor. And then when you do that, what you have is that 7 cancels 7, and a to the third over a squared leaves you with a to the first power. And then 7 goes into 14 2 times. And a squared over a squared cancels each other out. They become 1. And so this is a squared, or a plus 2, but don't forget your greatest common factor. So the factorization is this factor plus your greatest common factor. So always remember to put your greatest common factor back down. And for this one, we didn't need the factoring boxes at all. We didn't need to build a multiplication table. We could have, what we would have done if we had done the problem that way is remember that when you're factoring, you're undoing a multiplication. And so your product then is going to be what you start out with. And I didn't make my boxes quite like I wanted to, so we'll do this. And so what you do is you look for your greatest common factor here. And you see that your greatest common factor is, of course, 7a squared, because you have a factor of 7 in both of these. And you have an a squared. So then you ask yourself, what do I need to multiply 7a squared by to get 7a cubed? And of course the answer is a. And then you ask yourself, what do I need to multiply 7a squared by to get negative 14a squared? And of course the answer is negative 2. And so you see that your factors are 7a squared and a minus 2, just as they were doing it this way. So the factoring boxes still work, but a lot of people would prefer on greatest common factor simply to do it this way, because you remember your rules for exponents more easily this way. So let's look at another one. Here we've got 3y to the third power plus 24y squared plus 9y. And again, first step always is you look for that greatest common factor. That is always going to be your first step. And so I see that 3 will divide into 3, into 24, and also into 9. So part of my greatest common factor is going to be the constant 3. And I see that I have y squared, and y cubed, and so 3y is the greatest common factor. And again, I'll do it by the fraction reducing method, because that seems to be more familiar from students that I've taught this in the past. So you take each term, and you divide each term by your greatest common factor. And we see that 3 cancels 3, and that y underneath y cubed changes that y cubed to a square. And we see that 3 goes into 24 8 times. And y squared over y changes that to y to the first. So we have 8y. And then finally, 3 goes into 9 3 times. And y goes into y 1 time. And so our last term is a 3. And then we need to remember to bring back our greatest common factor. So we have 3y times y squared plus 8y plus 3. Now the question now becomes, is this part of the polynomial factorable? And to answer that question, we're going to see if it factors. And the way that we look to see if it factors and this time we are factoring. We're going to put these terms in, but we need to remember that if that factors, that y squared plus 8y, that 8y used to be 2 different terms if it factors. And so this is going to be our first term, and this is going to be our last term, which means this is going to go in our first box, and this is going to go in our last box. And the way this factoring method works is whatever goes in this box and this box has to be 2 factors of the product of the first and the last terms. So whatever goes in those 2 boxes has got to be factors of 3y squared. And so when I try to factor 3y squared, give myself a little room here. Since I know that my master product here is going to be 3y squared, and it's positive 3y squared, that tells me 2 or 3 things about what goes in those 2 yellow boxes. First thing it tells me is that both of them are going to have a y, because y squared is y times y. So it's not really the y that I'm worried about finding factors of. That's pretty easy. It's the factors of 3. And the factors of 3 are 1 and 3. 2 doesn't go into 3, so it's not 2 times anything. And then the last one is 3 times 1. But since I've already used the 3, I don't need to write out any more factors. This is the only factors of 3 and 1. The plus sign tells me that both of these factors either have to be positive or they both have to be negative. But the issue here is that 1y times 3y gives me positive 4y, and minus 1y minus 3y gives me a sum of negative 4y. And looking at the middle term that I need to have, this one is not what I'm looking for, and neither is this one. And since this is the only factors there are, then I know that this particular part of the polynomial is prime, meaning that part doesn't factor. That does not mean the original problem didn't factor. The original problem did factor into a greatest common factor of 3y times a trinomial. So we're going to try another one. And keep in mind that this did factor, but the trinomial that we've got from the greatest common factor didn't factor. That may not always be the case. So here we have one that's a little more challenging. We have 60m to the fourth plus 120m cubed times n plus 50m squared times n squared. And we need to look for a greatest common factor. And I see m squared, m to the third, and m to the fourth. So part of that greatest common factor is going to be m squared. Remember, you take your lowest exponent. And then 60, 120, and 50 all have a greatest common factor of 10. And so I'm going to divide the greatest common factor out from each one of these. And when I do that, 10 goes into 60 6 times. And m to the fourth over m squared makes that m squared. And then 10 goes into 120 12 times. And m cubed over m becomes just m. And then finally, 10 goes into 50 5 times. And m squared cancels m squared. And I have left n squared. And so initially what I have here is 10m squared times the trinomial 6m squared plus 12mn. Sorry, I left out the n there. Plus 5n squared. And so it is factorable, but the question is whether or not this polynomial in the parentheses is factorable. And you need to remember, once again, that this was originally two different terms. So we really would have had 4 terms here. So in order to factor this, we need 4 boxes. And I put these grids here just as a guideline. And so in our first box, we put 6m squared. And in our last box, we put 5n squared with the sign. And what we don't know is what goes in this box and in this box. But what we do know is that whatever goes in those two green boxes is the product of these two. And so that product is 30 m squared n squared. And so 6m squared times 5n squared is 30m squared n squared. And we know that both of these terms are going to have an m and an n because m times m is m squared and n times n is n squared. So we're really looking for the factors of 30. And don't be tempted to just jump to the first one you think of. Always start with the most obvious factors, which is 1 and 30. Then go to 2, and since 2 goes into 30 15 times, another set of factors is 2 and 15. And then you check and see if 3 works. 3 times 10 gives us 30, so another set of factors is 3, 10. 4 won't divide into 30 evenly. You can use your calculator to check that. 5 does divide into 30. It goes 6 times. And the next number we would try would be the 6, but since we've already got a factor that has a set of factors that has a 6 in it, we don't need another set of factors with 6, so we know that we're finished. And so both of these have mn all the way down. Now, the 30 is positive. We look at our middle term in our polynomial, and it is also positive. So that tells us that whatever we added together here had to be two positive numbers. So all of these are positive, and all of these would be positive. And so 1m plus 30m gives us 31m n, and that's not it, because it's not 12. 2m plus 15, 2mn plus 15mn gives us 17mn, and that's not it. 3mn plus 10mn gives us 13mn, so that doesn't work. 5mn plus 6mn would give us 11mn, but we need 12mn. So for that reason then, we know that this trinomial does not factor, and therefore our final factorization is going to be what we had before we tried to factor that. So our final factorization here is actually what we have here. (10m squared times 6m squared plus 12mn plus 5n squared). So our next example is a little bit easier than the first two. Okay, here we have a simpler one. The others have had larger numbers, been a little more complicated, but I'd like to focus on the actual factoring process with some simpler ones. So again, our first step always is to look for a greatest common factor. You always look for it, even if you don't think you're going to find one. But looking here, I see m squared 5m, but 14 doesn't have any variables with it, so the variable isn't the greatest common factor. And the leading coefficient is 1, and anytime the leading coefficient is 1, there's not going to be a greatest common factor other than 1, and other than 1, greatest common factor of 1 is pretty useless. So we're going to say the greatest common factor, we have none, which isn't to say there really isn't one, just not one that's useful, because 1 isn't a useful common factor. So for that reason, we're going to go straight to our factoring boxes. And we know that that trinomial that we're trying to factor used to actually be 4 factors, but the negative 5m is the combination of the 2 factors that lived in these 2 boxes. So we have those to leave blank, but we know what goes in the first box, that's m squared. And we know what goes in the last box, that's negative 14. So then we take the product of m squared and negative 14, and we get negative 14m squared. And some things that we know about that, the m squared part tells us that there's going to be an m as a part of both factors, because m times m is m squared. We also know that it's going to be the factors of 14, which are 1 and 14, or 2 and 7. 3 doesn't divide 14, 4 doesn't divide 14, 5 doesn't divide 14, 6 doesn't divide 14, and we've already used 7, so we know that's all the factors that we have. And then we need to figure out what to do about the signs. And what we know is that since that is negative, either the signs are negative and positive for the 2 factors, they're different, or it could be the positive factors first and the negative factors second. So what we do is we go and we look again at the sign of the middle term, and it's negative. So that means if we're adding 2 numbers together and we get a negative result, the larger number must have been the negative number, which tells us that our smaller factors are going to be the positive factors and the larger factors are going to be the negative factors. So then we check to see if either of these work. So 1m minus 14m gives us negative 13m, which didn't work. But positive 2m minus 7m gives us negative 5m, which does work. That is what we want. And so what we do is we put the positive 2m in one of the boxes. It does not matter which one. And the negative 7m in the other box. And again, it doesn't matter which one. And from there, we're going to go back to, guess what? A greatest common factor. We're going to look at just the first row and say what is the greatest common factor between m squared and 7m. And of course, that's m. So then we move to the second row and say what is the greatest common factor between 2m and negative 14. And 2 goes into 14, so that would be 2. but we don't know if it's positive or negative yet, so we're just going to leave the sign kind of hanging out there and see what we come up with. And so then we look at the first column, and the greatest common factor between m squared and 2m is, again, m. And in the second column, we look at negative 7m and negative 14, and we notice that both of those numbers are negative, and that 7 goes into 14, so our factor would be negative 7, which means this 2 is going to be positive because m times m gives us m squared. M times negative 7 gives us negative 7m. 2 times m gives us positive 2m. And 2 times negative 7 gives us negative 14. So the factors of m squared minus 5m minus 14 are m plus 2 times m minus 7. Now, just as a side note, the order that we put those in those boxes did not matter, except for the first and the last. As long as we put the first term in the first box and the last term in the last box, you can't go wrong because you're going to get the product of the first and the last, and it's going to turn out that it's going to be positive 2 and negative 7m. Last time I put the 2 and the 7 in this box and this box respectively. This time I'm going to switch that up and put negative 7m in this box and positive 2m in this box. But I'm going to follow the same process I did a minute ago. Greatest common factor across the first row is m. Greatest common factor across the second row is negative 7. Greatest common factor in the first column is m. Greatest common factor in the second column is 2. And as before, I check my signs as I go along. M times m is m squared. M times 2 is positive 2m only if this is a positive 2. Negative 7 times m is negative 7m. Negative 7 times positive 2 is negative 14. And so, it is equally correct that the factorization would have been m minus 7 times m plus 2. The place those factors wind up doesn't make any difference. You'll get the same answer either way. Both of those are perfectly correct. So let's try another one. We have x squared minus 4x minus 5. The first thing we're going to look for is the greatest common factor. But we notice, of course, immediately that the leading coefficient is 1, and there isn't an x in the last term, so therefore, greatest common factor doesn't exist. So we're going to see if we can factor this trinomial instead. So as we've done before, first term goes in the first box, last term goes in the last box. We're going to factor, and our product that we need is x squared times negative 5, which means both of our factors are going to have an x. And since 5 is a prime number, the only factors of 5 are 1 and 5. And the fact that it's negative tells us that our signs are going to be different. And the fact that we get a negative sum tells us the larger one has to be the negative one. And so the first one is positive and the second one's negative, which will give us a negative product. And the larger one being negative will give us a negative middle term. So if we have a chance of this factoring, this one has to be the one that works. If it doesn't work, we're done. Fortunately, in this case, it does work, because that product of negative 1 times negative 5 gives us negative 5x squared, but the sum is negative 4x, which is what we're looking for the middle term. So, again, it doesn't matter which one you put where. And now we look for greatest common factor. Greatest common factor along the top row is an x. Greatest common factor along the bottom row is negative 5. Greatest common factor in the first column is going to be x, because x squared and 5x have a common factor of x. And for the second column, it's going to be 1, because both factors here don't have an x, and the only thing in common between 5 and 1 is the 1. And since we need negative 5, when we multiply this 1 times negative 5, that 1 is going to be positive. So your last step is simply to check and make sure that everything's working. So x times x is x squared, x times 1 is 1x, negative 5 times x is negative 5x, negative 5 times 1 is negative 5. We have factored the trinomial, and its factors are x squared minus 4x minus 5 is equal to x minus 5 times x plus 1, or x plus 1 times x minus 5 because it doesn't matter what order we multiply in. So moving on to our next example, again, we see there's no greatest common factor. There's nothing in common between z squared, 9z, and 20. And so we go straight to using our factor boxes. And in our first box, we have z squared. In our last box, we have positive 20. And we are factoring. And the product of z squared and positive 20 is positive 20z squared. We know then that both of our factors are going to have a z. Since this is positive, we know that that's either the product of two positive numbers or two negative numbers. And the fact that the middle term is positive tells us it's the two positive factors that we want. So both of these columns are going to be positive factors. The factors of 20 are 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. 5 would be the next thing we would try, and we've already tried it, so we have a list of all the factors now. So plus 1z and plus 20z doesn't give us 9z. Positive 2z and positive 10z gives us 12z, and that's not what we're looking for. But 4z and 5z, when you add those together, gives us 9z. So that's what we're looking for. So that means that we want 4z and 5z in these two boxes. In either box, it doesn't matter which one. And now we're down to looking for greatest common factors. Greatest common factor between z squared and 5z is z. Greatest common factor between 4z and 20 is 4. And it will be positive because both of those are positive. Greatest common factor between z squared and 4z is going to be z. And the greatest common factor between 5z and 20 is going to be 5. And again, it'll be positive because both 5 and 20 are positive. And so the last thing remaining is to check that all of our math worked. Z times z is z squared. Z times 5 is plus 5z. Z times 4 is plus 4z, and plus 4 times plus 5 is plus 20. And so therefore, z squared plus 9z plus 20 is equal to z plus 5 times z plus 4, or z plus 4 times z plus 5. Here we have what appears to be a binomial, and in fact is a binomial, but keep in mind that it is possible that your binomial is still the result of multiplying two other binomials together to get it. We'll still follow the same process. First thing we'll look for is the greatest common factor. So between 10x squared and 160x, we have a greatest common factor of 10. And so if you divide 10 into 10x squared, you will get x squared. And if you divide 10 into 160, you will get 16. And so the question becomes, does x squared minus 16 factor? And if it does, we're always using the same process, because even though x squared minus 16 is a binomial, it could be the simplification of a trinomial. Where it had two middle terms, but those middle terms have to be the same because they canceled each other out and made a sum of 0. We're still going to follow the same process that we did before. We're going to put our first term in our first box, our last term in our last box, take that product, and knowing that that product is negative means one of our signs is going to be positive, one's going to be negative, and the fact that the middle term has disappeared tells us that it's going to be the same numerical coefficient. But we'll still start with our factors to make sure we don't miss any. So 16 is the product of 1 and 16, so that would be 1x and 16x, or 2x and 8x. 3 doesn't work. 4x and 4x. And since those are the same and one's positive and one's negative, we have found the ones that we're looking for. Because those equal 0x, and our middle term has disappeared. So then again, greatest common factor across your top row is going to be x, and across your second row is going to be 4. And then greatest common factor in your first column is going to again be x. And in your second column is going to be negative 4, which tells us this 4 had to be the positive 4. And so our ultimate product here x squared minus 16 factors into x plus 4 and x minus 4, but you never forget your greatest common factor. You carry it through all the way to the end. And so your factored form of 10x squared minus 160 is 10 times x plus 4 times x minus 4. So here we have another example, and the first thing that we notice is that since there's an a squared in the first term and a b squared in the last term, and there's nothing common to either of those, and our leading coefficient is again 1, we know there's no greatest common factor. So then we will proceed straight to using our factor boxes to try to figure out if this factors. And so in our first box we have a squared. In our last box we have positive 5b squared. And we are going to factor, and our product is a squared times 5b squared, so it's positive 5a squared b squared. And we know because it's positive, we either have to have two positive factors or we have to have two negative factors to get a positive product. The fact that our middle term is negative tells us that both the factors then must be negative for this to work. And we know that there will be an AB in both of these. And 5 only has one set of factors, and that's 1 and 5, or 5 and 1. Order doesn't matter. And in this case, if this doesn't work, then our polynomial isn't factorable, but it does work. Minus 1ab plus minus 5ab gives us negative 6ab. And so greatest common factor across this top row is just a. Across the second row is just b. In the first column it is again a, but in the last column is 5. And since we need positive b here, but we need negative here, then that 5's got to be negative to make a times negative 5b be negative 5ab. And by the same token, this b has to be negative, because negative b times a to be negative ab, that b would have to be negative. And of course, in our final check, negative b times negative 5b gives us positive 5b squared. And so our factorization is a squared minus 6ab plus 5b squared equals a minus b times a minus 5b. And hopefully by now you're getting the hang of this, but if not, be sure and ask questions. So here we are in our last two problems. We have 3x squared plus 4x minus 7. We look for a greatest common factor, but 4 is even, 3 and 7 are prime, so there's not going to be a numerical greatest common factor, and the 7 doesn't have an x, so there is no GCF. Then we'll proceed with trying to factor what we have left. And so in our first box, we have 3x squared. In our last box, we have negative 7. The product of 3x squared times negative 7 is negative 21x squared. The fact that it is negative 21x squared tells us that either both of our factors have different signs, and they're either going to be positive negative or negative positive. The fact that our middle term is positive tells us that the larger factor is going to be the positive factor. And we know that both of them are going to have an x. So we need the factors of 21, and again, don't jump ahead. Always go that first one, because the very first time you leave it out, it'll be the one that you wanted. So negative 1x and positive 21x. Negative 2 is not a factor, so we'll go with negative 3. Negative 3x and positive 7x. 4 doesn't work. 5 doesn't work. 6 doesn't work, and we've tried 7. So these are all the factors that we have. Negative 1 plus 21x gives us 20x, which of course is not what we're looking for. Negative 3x plus 7x, however, gives us positive 4x. So those are the ones that we're looking for. And so we put those in our other two boxes. And the greatest common factor across your top row is just x. And across your second row, the only thing those two have in common is their negative sign. So that's actually a negative 1. Greatest common factor on our first column is 3x. And greatest common factor on our second column is the 7. And that 7 is going to be positive because when we do the product of negative 1 and positive 7, that'll give us our negative 7. So the others check out as well. X times 3x is 3x squared. X times positive 7 is 7x. Negative 1 times 3 is negative 3x. Negative 1 times positive 7 is negative 7. And so our factorization that we're looking for is 3x squared plus 4x minus 7 is equal to x minus 1 times 3x plus 7. And for our final problem, we have 9x squared plus 64. And once again, a reminder, 9x squared plus 64 could have been a trinomial. Which means it could have factored, because the 0x could have been the sum of two terms one positive and one negative with the same coefficient. We'll begin as usual. Between 9 and 64, there is no greatest common factor. So we're left with only the 9x squared and the 64 to give us any clues. So we'll start with 9x squared plus 64. And the product of that is going to be rather large. But our process still works. So 9 times 64, we'll grab a calculator here. Is 576. And 576 is going to have a lot of factors. Now, we can list all of those factors, and it will work, and you'll eventually find what you're looking for if this, in fact, factors. But it might be easier if we consider prime factors of both of the numbers we have. So I showed you before how to make a prime factor tree. 9 is divisible by 3. It's 3 times 3. And 3 goes into 3 one time. At this point, we know that we're done because 1 is the smallest prime. And so 9 is 3 times 3. 64 is even. And 64 can be divided by 2 and we get 32. By 2 again and we'll get 16. By 2 again and we'll get 8. By 2 again we'll get 4. By 2 again we'll get 2. And since 2 goes into 2 one time, we have 1, 2, 3, 4, 5, 6 2's. Three times 3 has no factor in common with 2 times 2 times 2. 3 doesn't go into 2, 2 doesn't go into 3. So we would say that the numbers 9 and 64 are relatively prime. Neither of the numbers by itself is prime, but in relation to each other they are prime, meaning they have no common factors. What that tells us is that there is no factorization of 576 that would give us a pair of factors that would cause the sum or the middle term to disappear. And therefore, oops, wrong pen. 9x squared plus 64 is prime. Now, even though you wouldn't necessarily want to do this, I am going to go through and give you the set of all the factors of 576. And of course, there's 1 times 576. Then there's 2 times 288. Three times 192. Four times 144. 5 doesn't work. Six times 96. 7 doesn't work. 8 times 72. 9 times 64. 10 doesn't work. 11 doesn't work. 12 works. 13 doesn't work. 14 doesn't work. 15 doesn't work. 16 works. 17 doesn't work. 18 works. 19 doesn't work. 20 doesn't work. 21 doesn't work. 22 doesn't work. 23 doesn't work. 24 times 24. And as soon as you get two that repeat, you know you've gotten all the factors. So while it's pretty obvious that none of these, with both of them being positive, is going to give us a 0. None of these, both of them being positive, is going to give us a 0. If these are both positive, that doesn't equal 0. If these are both negative, that doesn't equal 0. So those two are relatively prime, which means that our polynomial 9x squared plus 64 is prime, because we had no set of factors here that would give us a 0 for the middle term. This is the best thing about the factorization method that I use, because you will know when your polynomial doesn't factor as well as when it does. If you want some extra practice, there's some in the textbook. So if you want to practice with a few more, look on page R8 in your e-text. The answers to all of those problems are at the end of the textbook. And I will be posting a video of 10.4 and 10.5 before Monday. Have a great weekend.